What's up, you all? This is Hussein Nasser from IGeometry bringing you the third episode of Docker and ArcGIS. So, in the previous episode, we discussed the file system usage of ArcGIS. So you can have. Oh, I fixed the mouse. Now I can show the mouse in the keynote. It was just a setting issue. Yeah, I don't know why this is disabled by default. Yeah. So you have your ArcGIS client and you have your file system, could be local, could be on a file share, and you consume this, right? And this is a valid option. You can always have local files working. Is it a production? Uh, is it a production solution? Obviously not, but it could be very useful for local editing and if you want to browse something, right? But these kind of things are really getting less and less popular as we go into the cloud technology and all these kind of things. So yeah, so we discussed this and we discussed how we can apply Docker in this, right? So we said that we will Dockerize the entire uh, Linux repo with either Quantum GIS or ArcMap for Linux, which doesn't exist, by the way. So it would be good that it exists, but it doesn't. So, well, and you have your own file system, so you can have these replicated and you can have to connect and you can create containers with all these data and with a ready-made. So this is very similar to a virtual machine, although it's much more efficient. So people will remote into these containers. So that's the idea behind that. All right, so there are some technical things here like networking, and I'm not gonna discuss it here. And we will move to the next one actually, where we'll discuss this in this episode. Right, so client server. All right, who doesn't like client server, right? So let me see, are we recording? Yes, we are. So you have yourself your client. This is a thick client. Could be ArcGIS Pro, and these guys connect to the database, which is on another machine. Could be in a local machine. That does nothing stopping you from that. But usually it's in another server and you connect using the IP address or the host name of this machine, which has the enterprise geodatabase, and then you consume, read, write, that is editing, do all the kind of cool things. So this model has been very famous, in the past 20 years or so, and is still used to this day. So what is the advantage of this? So obviously you have more control over things here. So you have your client and the database is just over the other side. So you can connect to it using a networking mechanism and then you consume it, right? So the you can edit, you can view all the kind of things you can do with these things because the database client is installed on this client, whether it be ArcGIS or Pro, and then Pro consume that client, and that client talks to the database, right? So that's how it works. So what is the disadvantage of this? I think we talked about this in the previous one. We mentioned Citrix and all these things. The disadvantage of this, you have to install a lot of dependencies in this machine, right? In order to communicate with that, right? That's what led to the cloud and server technology and all these things. All right, so this is not our topic today because we discussed this in the previous episode. In this episode, we can discuss how can we dockerize this particular architecture. So, how can we do this? All right, so from we cannot use Docker at this side. Why? because unfortunately we don't have ArcGIS or ArcMap for Linux, because Docker now runs only for Linux, so we don't have that. But I can do this on this side. Why? Because I have Oracle for Linux and I have Postgres for Linux. Recently, they just released a SQL Server for Linux, but I don't know if Azure gonna support that or not. So, but we have some options we can do here. We can Dockerize the database, the DBMS, the database management system itself, the geodatabase. We can Dockerize it. So let's see how can we do that, right? So this is an episode where we can just think out loud and see what we can do. All right, so let's assume this is my client, right? That's my database. I'm gonna pick one database. I'm gonna pick Postgres, for instance, here, right? So this is my Postgres instance. So what we can do is the following. We can Dockerize the enterprise geodatabase here. So what advantage will this give me? Let's think about that. So what we can do is, if we have this database instance and we have the geodatabase on top of that, obviously installed, we have our data, it's nice and ready. Okay, so we did that. So this is our Postgres instance. Let's add a text here. So Postgres. All right. So that's Postgres. And then what we want to do is we want to Dockerize this instance into multiple instances. So what we do is basically, let's steal this icon. Dun dun dun. What? Send to object. Nope. Nope. I don't know how we do this. Send to back. Yeah, there you go. So there is my Postgres instance. Let's just delete that. So we have one Docker container running Postgres, and another Docker container running also Postgres, and another Docker container running Postgres. 3 Docker containers running Postgres. How about that? Right? So this is the interesting thing here. It's a very challenging thing. So if we have 3 instances running this Postgres geodatabase, what we can do is basically connect to each one of them, right? This is what we can do. This is one option that we can definitely do. We can directly connect to this Docker instance. We can connect to this Docker instance, or we can connect to this Docker instance, right? So we have many options. So no longer we have the overhead on one database anymore. So we can Dockerize that, right? But so what happens that this architecture is really good, really good, but there's one problem here. All right. So there's reading, all right, and there's writing. So you can, for example, using ArcGIS or ArcMap, let's say you have a huge data set of a telecom communication, right? You have your utility, which is a telecom utility, and you don't want, let's assume just you want to consume this for reading, all right? You want these people to run analytics, for example. That's a good example, right? Analytics doesn't do editing. So You just want to analyze this network, do some analysis on top of it, generate some reporting. So if you just used one database like this, and you every single client, you have multiple clients, actually that would be a good example to have. You have multiple clients connecting to this database, because you can do this obviously, right? Nothing stopping you. What is the problem with this? The problem is that this database will become overwhelmed, right? Cannot serve this much client, can't serve so much clients. I mean, yeah, if you have like 3, obviously this doesn't have a problem with it, right? It will serve it easily. But if this scales to 100, then okay, this start to be like a little problem, right? The enterprise database processing will just goes up and up and up. So this is a good idea. So how can we solve this without Docker? Without Docker, you bring another server or another virtual machine and run these stuff. So with Docker, and duplicate basically your instance here. With Docker, what you can do is basically have the same operating system and Dockerize the Postgres instance, all right, on top of each one, right? So you still have the same operating system, right, which is Linux, but you can have multiple Docker containers running on that Docker instance. So if one instance, for example, if this is not enough, just literally just say Docker one container and specify the image which has your telecom network, and boom, you have a new Docker container. And then just basically people will start consuming this, you know? So that's the idea, right? So let's go deep into this, right? So this is, let's say, Postgres containers, Postgres Docker containers, right? Running geodatabase, ArcGIS geodatabase. So this what happens that when you can communicate with these containers, you cannot really just use the IP address of the container. So when I said here, I actually lied. I didn't want to go into details, you know. Correct. Each container has its own IP address, all right? So what happens that, so let's create another, we need to, yeah. So each container does have its own IP address, and let's assume it's, I don't know really what is it, but I'm just gonna give an example here, right? I don't remember what is the range of these containers, right? So let's just say, obviously it's an internal address, right? So it happens that this doesn't really work this way. All of these guys don't communicate to the individual containers. There is one guy, all right, one machine. I need a server. Yeah, let's take this. Let's steal that. There is one machine that actually has Docker installed on top of it, all right? And these guys connect to this machine. So this is really confusing now, right? But we're gonna explain it in just about a minute. Some of you might say, Hussein, why don't you just do the PowerPoint and explain it to us? Because it's boring. You have to suffer with me on doing this PowerPoint presentation, right? Because I don't like making PowerPoints. Right? I'm not a teacher, obviously. Right? So you have to watch me do this. Suffer like I suffer. Alright, so this is a server running Docker, right? So what happens that this guy connect to this server, all right? So let's say this IP is 192. This I know, it's always 192. It's not always. think that 100. From the time I use Docker, it's always giving me this IP address, all right? Unless there's a case that you get a different IP address, I don't know. That's the thing. Each Docker container, when you expose a Docker container, you can also expose a port, because Postgres running on a different, that's the thing, right? Each database runs on a server, obviously, and needs an IP or a host name, and it needs a port to expose this communication, right? So the port for Postgres is, if I'm not mistaken, is 5432, maybe? I think it's 5432. So each Docker container, 5432, right? 5432. So you can do that, right? Nothing's stopping you. You will have this container running on this server. This is the IP address, and that's the port for Postgres. The problem is that you cannot actually connect from this machine, which is outside this subnetwork, obviously. This is all pure networking stuff, right? So you cannot connect from this to this. But you can connect from here to here, which is the host of the all these containers. It's actually, these containers reside on this machine. All right. So what happens that, let's put this here. So what happens is that when you expose a port via container, you specify what port maps to the outside world. All right. So for example, the first server here, 5432.10.0.0.1, I want to expose it through port, let's say, I want to expose it through port 1111, right? So if someone tried to connect to 192.168.1.100.1111, he will be directed to this container and this port. So this guy have to access that machine, right? That's how it works. And let's make this smaller. Alright, where is the... This is very confusing. How can we make this smaller? Alright, there you go. So this, and we expose this port on, let's say, 2222, and we expose this container on 3333, right? So what happens is that when you want to connect from this machine, let's say I want to connect to 192. So this machine connects to this. This machine connects to this. And this machine connects to, for example, this, right? So if this machine connects to 192.168.133, it will be directed to this Postgres instance, which is the geodatabase. If this guy connects to this, he will go here. This guy connects to this, he will go here. If we make another machine request through this port, same port, 9222, this will go here, right? So you can establish this kind of connections, but there is a lot of problems here, right? So we solved something here, right? We solved the problem of duplicating stuff. So I have my machine, my geodatabase, which has this huge data set of telecom communication, for example, and I want to duplicate it on so many servers, and I don't want to worry about I don't want to worry about I want to make this setup a high availability, so I just spawn another container, but the problem with that, every container I spawn, I have to map it with a port, and I have to let this client know about these ports, right? So you need to install some other layer here that take care of all these weird thing, because when you want to connect, right, to an instance of ArcGIS Enterprise Geodatabase, you have to specify this, you have to specify that, and the username and password, and you connect, right? So this is the variable thing. The port number is something that's changing, all right? That is the variable information here. It's changing. So we have to make this as simple as possible for the client itself. The client shouldn't worry about changing stuff, right? So things like network load balancing comes really handy here. You can add all these machines in like a text file and have a program connect to all of them randomly, connect to each one of them randomly. So you establish some sort of this is not even load balancing, this is round robin. So this is really good, right? So what we just made is like we made a high available thing, right, set up out of our Postgres instances with ArcGIS, right? So this is cool. One problem though. What if I want to edit? All this goes to shit, right? If I am connecting here, all right, so from 111, this will give me this, right? This container. I went and edited and deleted something, right? Deleted some network or added something else, right? And this user connected here and added another network or added some towers to my utility network, utility telecommunication. We keep changing. These guys will eventually become out of date, right? These will be out of sync, not out of date, out of sync. This have some changes. This will become dirty. This will become dirty. So how do we solve the problem of editing, right? So how do we solve the problem of editing? So with editing, it just becomes really interesting, right? What happens with editing is that these changes become isolated. And with reading only, if you made these guys read only, this is a really great setup for you, you know. And I actually tried that, and it worked. I could create multiple containers with multiple ports. These still run on the same port, Postgres instance port. You can change that, by the way. I don't know why would you do that, but you can keep that. But this you have to change, because if you keep the 445432 here, you cannot reuse it here, obviously, because this port is already in use. All right, so what happens that so you have to make sure these are in sync. All right, so with reading, you don't have a problem. These guys are, you are reading, you're fine. You can bring a million machine here and we still gonna make some sort of load balancing, right? So this is the idea of client server architecture with Docker. What happened if I want to edit? Let's go back to this. So reading, no problem. Editing, on the otherwise. So what can I do with editing? With editing, there's one solution that I can think of, right? If you start editing these containers, right, you have to be very, very careful, you know? You have to make these databases in sync, right? So one solution is to do a two-way replica. How can I do this two-way? There, really? There's no two arrow? Oh, there you go. Boom, that's real big, man. All right, so you can do a two-way replica here. We can do another two-way replica here. There you go. Once you do two-way replicas, if you start editing, these guys eventually will become in sync. All right? So that is one proposed solution to do that. If you guys think you have another uh, you can propose another solution to this editing problem, please feel free to contact me, write it in the comments, and let's discuss it. All right. So one idea is just basically you can sync these Docker containers with replication, and the replication is an out of the box thing in Geodatabase, so you can replicate uh, the actual enterprise geodatabase at the geodatabase level. You can do replication at the database level. There are so two kind of the replications. Replication from the S3 level, so geodatabase level. So these are only syncs, edits, and there are another level of the database is that the first level is that it syncs the actual edits, which are basically features that had been created, all these kind of things, you know. But if you did it from the database level, what changes is that you are syncing between the actual raw rows, you know. So that's the difference. So you're syncing tables, a bunch of tables. Right. So in the enterprise, if you do the geodatabase application from the enterprise level, you're syncing data sets, you're syncing feature data sets. Those the geo as Israel is aware at that level. You can sync versions, right, together. You cannot do that at the database level. You know, for example, if you are running on a version A here and version B, you can replicate those versions together too. So that's the idea of replication between that level and that level. All right. So I think this is all I have for today. I'm going to discuss. This is my favorite part of Docker, really, here, where we apply Docker in a really, really productive way here. Here, not so much. I still feel there is. It's okay, you have Docker containers in the read-only environment. Let's say this is this is really interesting, okay? And the replication things get really complicated, you know, and you have to make sure these are sync. So I don't really think it's a good idea to use Docker if you're editing stuff, unless you have a very robust way of doing it. So we'll keep thinking of a solution maybe to this problem, but we'll see. But with reading, let's say if you combine this with ArcGIS server, then this will be really powerful. You know, you can basically have many enterprise geodatabases instances and replicate them. No, you don't have to replicate them, just have them there, and you can consume these instances really in a very efficient way. All right, guys, I hope you enjoyed this really short episode. I hope I didn't miss anything today, but you understand this concept, right? So we have a host, a Docker host, and this guy connects to this host and points to this. Similarly here, there is a Docker host in the middle, right, that you have to connect to. If you want to RDP to this, you have to expose the RDP port and become the same concept, right? This has a port, and this has a port, this has a port, so you have to expose it to the Docker machine, and then you remove it into it. So this is another implementation of Docker. Things are getting exciting, huh? Things are a little bit tricky, but exciting nevertheless. So, hope you guys enjoyed this episode. Short, but to the point. All right. Let me know if you have any questions, any insights, any Docker experts out there. Please add your 2 cents here, and let's see. And if you do like this, there's not much to ask, but leave a like, add a comment, subscribe, share this video. All right, and it means really, it means a lot to me if I see all these comments. All right, guys. All right, you stay awesome. See you in the next one. I have to go back to the ArcGIS add-ins. People are asking, when are you gonna go back to that series? Right, so I stopped that. I can only record one episode per week because I'm busy with work and all these things. But yeah, we'll try my best. All right, guys. See you in the next one. Bye bye.